Neurosurgery is terrifying for both the patient and the surgeon. For the patient, they're put in a situation where they're no longer able to control their health or their bodies. But for the surgeon, not only do they have to do a surgery, they also have to deal with the fact that a few millimeters could be the difference between a patient recovering or a patient never being able to walk again. Naturally, for the greatest chance of success, the surgeon should be able to see everything within the surgical site. In an ideal world, after the proper incisions are made, the surgeon might be able to see something similar to the right image. But we don't live in an ideal world. In our world, do you know what the surgeon sees? Red. It's the human body. When you cut into the human body, you're going to see a lot of blood. But in a scenario where a few millimeters can make or break the surgery, it's a bit unsettling to know that all the surgeon can see is different shades of red. Currently, we have the technology where we're able to visualize the spine and the surgical tools being used onto a screen. This provides the surgeon with visual feedback, and they're able to know where they're operating with respect to the spine. However, this also means that the surgeon is constantly alternating between looking at the screen and the surgical site in front of them. And as you can imagine, this can be very time-consuming and very fatiguing for the surgeon. It's a good solution, but there are better solutions out there. Neurosurgery equipment has not yet been able to take advantage of advancing technologies. Things such as AR or augmented reality, despite the fact that it can greatly increase the standard of care in neurosurgery, has not yet made its way into the operating rooms. And that's where my research comes in. With an augmented reality headset, I want to be able to provide the surgeon with a spine model that they can rely on during surgery. On the left-hand side is some of the results that I've gotten. I managed to overlay a spine onto a patient in the real world. The end goal of this is to have a holographic image of the spine that can be superimposed onto the patient. The spine model will appear on the lens of these AR goggles, and the surgeon will be able to see both the spine and the patient as they're making their incisions and excisions. All the surgeon has to do is to put on these augmented reality goggles before they head into the operating room, and the spine in front of their eyes would automatically align with the patient's spine in the real world, giving them a valid point of reference throughout the entirety of the surgery. Hopefully with this, decision-making will be improved in neurosurgery, the times in surgery will be reduced, and the success rate of surgery rises overall. Thank you.